So you've got this full
Yeah.
time interval. Walk us through that again. Like what exactly happens during that 5 second interval? Is there some kind of like future, like in the way with text that, we're trying to figure out based on this statistical interpretation of across a large corpus, like what's the likelihood of the next word
Yeah.
being, X or Y? Like, is it a similar process? And if not, how's it different?
As I said, this is not really the image world we're in right now, right?
Yeah.
But these latent diffusion models, right? The way to think about them is abstractly. You have an image, and you apply a function to it that is adding noise, and you iterate this function. So as you iteratively apply this function, the image goes from a true image and ends up in being a noise pattern. What you're training the model on is the inverse function. So essentially, it's a noise removal function that the model is learning,
Gotcha.
right? So what it really needs to learn to do that is it kind of looks at correlations and how these correlations are still maintained somewhat in the distribution as noise is added, and is trying to compensate for that.
It's
And
basically
as
learning like visual structures in order to do that. Yeah.
exactly, that's exactly what it does, right?
Hmm.
And so that's how these latent diffusion models for images work, right? You give it some noises input, potentially some conditioning information like textual prompt, right? It's the same embeddings or combined embedding space, right? And then this model really tries to reverse the noise process. So it's denoising that until it comes out with an image that is then being presented to the user, or in this case, this image happens to be a spectrogram,
So
and
then
we run it.
it's learning that inverse function is learning the audio structures
Exactly,
basically,
exactly,
because they're manifested visually in this case. But yeah.
exactly. But of course, there are also these kind of systems. I think you've been looking or kind of getting at, right? So similar to
Uh-huh.
how I do textual structure, and I'm predicting, right, the next word or the next
Right.
paragraph, something about it. There are also these music LM, right? For example, music language models, which really apply the same kind of transformer architecture. Now it's applied to a presentation of musical events. So again, this can be a spectrogram, or it can be even more abstract, just the melodic patterns or harmonic patterns, right? That
Yeah,
it's
I've even seen it with just time series signals. Like it's
yeah,
actually taking this time
exactly.
series.
For example, like the MIDI information for
Yeah.
those, right? So
Yeah.
MIDI is a way to essentially represent digitally what a playing is doing within hitting the keys on a keyboard, right?
Hmm.
So it's not the actual audio, but it's kind of what is the input, right? Which note is played when and with what intensity. And so quite a few of the systems, they essentially are trained using large databases of these MIDI tracks. And then it's fairly straightforward because it's just time series, right,
Hmm.
as you're describing, right? To apply a regular transformer architecture that would predict the next note or a repetition of the next musical bar, and then refines it into the actual notes that are being played.